Okay, this next example speaks to the property, the addition property that gets used when simplifying rational expressions. I've written a little example here that says 4y, so 4 times y divided by x squared, plus 2 times x divided by x to the third power. And let's say I wanted to simplify this as much as I possibly can. Well, the first thing I see is in the numerator in the top. 4 and 2 have a common factor of 2, so that's something I can work with. And in the bottom, I see 2 terms made up of x, but one is x squared and one is x to the third power. So at first it may not seem that I can combine those, but if you look in the second part, after the plus sign, the second term, the 2x divided by x to the third power. And by the way, when you hear people in topics such as algebra use the word term, what they're referring to is, for example, here, this would make up a term. It's a part of the expression or a part of the equation that within itself is a combination of constants and variables that is then added to something else in the expression or equation, which is what's happening here. So let's see what we can do with this right term. Well, just like before, when we were working earlier, there's an x in the top and there's x to the third power in the bottom. Well, x to the third power is nothing more, another way of writing that, and what I'll do is say equals, to note that what I'm about to write is equivalent to what we started with. I'm gonna go ahead and break down that 4 in the left term and write that as 2 times 2, so I'll make use of that in a moment, times the y. And I'll say something about the little y in here in a moment, why we're not doing anything with it right now. And the bottom is x squared plus 2 times x. And in the bottom, I have x to the third power. Well, x to the third power is nothing more than x times x times x. So x times x is nothing more than x squared, still times the other x. And for the sake of what I'm trying to achieve, the second option is more useful because it gives me something that I already recognize in the expression, which is the x squared times x. So now, I've rewritten this expression in an equivalent manner. It says the same thing, it just looks different. But by writing it this way, I see 2 things that I can make use of. First of all, I'll get to the x first and go back to the constant. In the right term, I see that I have x over x, which cancels to the 1 over 1 we mentioned earlier, so it has no effect now. And I see that I have a 2 in the top part of the right term, and I have 2 2's in the top part of the left term. And I also see that I have an x squared in the bottom part of the right term and an x squared in the bottom part of the left term. So I now have a common denominator that I can make use of. From our grade school arithmetic, if we had 2 fractions, let's say 1 over 3 plus 5 over 3, another way we could write that is 1 plus 5 over 3. We would look for a common denominator. Well, in this case, since it's arithmetic, we can go ahead and carry out 6 over 3 and 2. But when you're dealing with expressions that have variables in it, like y or x, you can't go all the way down to 1 numbers. You can only go as far as you can go based on the information you have. And the information we have will let us take it one step further. We've gotten rid of these 2 x's over each other. I've marked through those. In the bottom, I have x squared. That's a common denominator, so I don't have to write it 2 separate times. I can use one common denominator now. And in the top part, I have the 2 times 2 times y, and from the right top part, I have just the 2 left over. Now you're probably thinking, why did I write the 2's out that way? Well, if you were given an expression like the original one, let's go back over to our original expression, and let's say you were told originally that this equals 0, which is oftentimes in the case. For example, in algebra, you'll be given some kind of problem that was x squared plus say 2 equals 0, and they want you to solve for x. So it's not unlikely that you will be given an expression like this and be told that it's set equal to 0 and asked to solve it. And so the whole reason we're trying to simplify this expression is we must do that before we can attempt to solve it. So let's say that was the case. Let's say we had been told, not only asked to simplify this, but we were told that it's set equal to 0. Well, if it's set equal to 0 over there, it's set equal to 0 over here. That hasn't changed. Well, what happens then? Well, now I can take it one step further, and I can make use of the following. 0 divided by any numbers is still 0. 0 divided by 3 equals 0 divided by 1 equals 0. And so what I can do here is I can make use of that, and I can factor out the 2 that I have in common in the top. And I can rewrite the top as 2 times, and in algebra the parentheses symbol will get used as a multiplication symbol when you're dealing with a term. 2 times 2y, because I had 2 2's and I divided 2, I pulled one out or divided 2 by it and was left with 2y. And if I pull out the 2, I'm left with 1. Now, I know I'm stretching this topic a little, so you may be getting a little confused, and that's okay. It'll become clear as we go along on different topics. It'll make clear what I'm trying to say here. I just want you to see how this practice of simplifying expressions actually will come into play in solving problems as we move along. So all I've done here is I've rewritten the numerator. I've rewritten it from this more involved form to the cleaner form of where I've pulled out the 2 that both parts have in common. Well, why have I done that? Well, part of the practice that you'll see in algebra as we move along is you'll look for things like this 2 here that can be, put it in layman's terms, gotten rid of, that we can get rid of because it'll make our equations simpler to deal with. Well, how can we get rid of it? Well, when you have an equation, as long as if it starts out true, it remains true if you do the same thing to both sides. So, for example, if I want to divide both sides of this equation by 2, I can. For example, down here where I have some white space, if I have 1 equals 1, and I divide both of those by 2, it now says 1/2 equals 1/2, which is equally as true. So I still have an equality. The equality holds, as some people would say. So I want to divide out this 2. I don't want to have to keep up with this 2. Well, if I put a 2 down here, if I divide by 2 here, I have to divide here by 2. Well, now this 2 goes away because it's taken out by this 2. 2 over 2 is just 1 over 1. Goes away. It's insignificant to us now. And here, we just agreed earlier, or reminded ourselves, that 0 divided by any number is still 0. So now, with very little effort, I've simplified this expression even further, down to the point where I can write it down here near the bottom in the following final form of, let me get rid of that. The numerator now just says 2y plus 1 equals x squared if it's equal to 0. And so that would be the final form if we were told that it was originally equal to 0, because we were able to make use of what we just talked about and get rid of that 1, 2. I know this went a little beyond just simplifying expressions, but in a real way it didn't, because we really haven't even started. Now we're at this point, we are now at the point of trying to solve the equation. So we really are still just talking about simplifying expressions. The only thing I added was I made use of the fact that we added onto our problem statement that the expression that we started with in the top left was set equal to 0. So we really haven't actually solved anything yet. All we've been doing up until now is simplifying the expression. And now is the point where you would actually try and solve. Now I said earlier I was going to get back to the y. I intentionally included y because sometimes they'll do that on exams. They'll throw in a different variable to try and confuse you or make you feel somewhat hesitant that you can't simplify it simply because the y is there. In terms of just simplifying the expression, the y plays no part. It's like a silent player. It's like one of these people you'll see in a movie that has no speaking part, right? It just sits there. It's there, but for the sake of what we're trying to do, simplifying the expression, it in no way prevents us from doing what we've just done. All that happens is at the end of the problem, when we're through simplifying, our final, most simple form that we can produce for our final answer will still have the y there. So if you're ever taking an exam and you're asked to simplify an expression, and several parts of the expression have a variable like x that you can work with, and one part, or even more than one part, has other variables like y or z, don't let that intimidate you into still trying to simplify. Just remind yourself that they may just be silent players, they may just sit there and do nothing for the sake of the problem you're being asked to solve, and that your final form of the expression will still have those variables y or z or some other variable there, and you simply won't be able to do anything with those. Okay, I'll stop here and go on to the next property in the next video.